Welcome to the third and final part of Competency 12 quiz questions. In this video, we will continue with questions involving geometric properties. Number 11. Quadrilateral ABCD is a kite in which AC is the longer diagonal. The diagonals intersect at point E. Which one of the following is false? Okay. I added the basic kite shape here for us. However, there are some things about kites that you need to always remember, and that's what they're trying to ask you. Okay, this is your shorter line. Oh, and again, I am challenged. My drawing is always so challenged. Okay, there it is. All right, now, what do we have? Let's see here. We have right angles all the way around. Okay. And we also have a congruency here and here, here and here. Now notice that AC, we can't have a congruency between those segments, okay? Right here, let's make our right angle look a little better. There we go. Okay, now we have a congruency here, okay? And also we have some angle congruencies, okay? So let's look at our options, and I think that's what they're trying to get to. Here, yeah, I am using a smaller one. Okay, so we have congruency with this angle, obviously in this angle, and up here it's C, okay? But we do not have congruency over here with these side angles, okay? That's just something that we've always got to be cognizant of. Cognizant. Okay. And I'll go ahead and do this with 2 and this one with 2. Okay. Actually, yeah, that'll work. All right. So let's see here. They're saying that we have two similar angles at A. We're looking at B. Oh, I need to turn this off. Looks like I got my shape thing on there. Didn't realize that. Okay. All right. So I wanted to point out that there's no congruency there. Okay. All right. So here's the thing. If we have A, B to D, that is this angle B right here. Let me change mine right here. This angle, there's not congruency at angle B. And you can quickly note that by looking at this center part. You see that they're trying to show that those two angles at B would be congruent, and that is simply false. That is not true. So it says which one of those following is false. So I would say this one can't be true. But let's look at the others. Okay. AC going from, that's the longer diagonal, and BD, well, that's the other diagonal. Well, that's true. They're always, if they tell you the shape is called a kite, okay, then you know that you'll have that perpendicular situation. Okay, so that's not going to work. Okay, so C, right, they are trying to compare the angles at A. Let's go over here to A, right? And yes, those angles are similar. There is congruency. So that's true. So it's not what we're looking for. We're looking for false. Okay, so let's see here. Oh, okay. And I have actually marked that. It says DE, which E is your center, which they said and I didn't mark. Okay, this is your E. Okay, if I could write. So that center is E. So DE, yes, those are congruent. I already marked those. So that's not what we're looking for. So A is the only option that can be true. Okay, now let's look at 12. Given the image of the triangle to the right, what is the value of DE? Okay, and notice down here BC segment is the value of 10 units. Okay. They're trying to see if you know the basic properties of the mid segment, which is this guy right here. He is called mid segment. Okay. That property says that mid segment is half the base. Okay. So that is option D. And how do I know that? Well, I know that it's a mixed mid segment, okay? And I know this because it looks like it's in the middle, but it's a little deceptive. But what they've done for me is they've given me these hash marks, tick marks. So that shows me that that's lines of congruency on both sides. So whenever you see that, you know you have a mid segment situation. And that tells me that that's half of my base, okay? But you must have this congruency here with the sides, okay? That has to happen. If they tell you it's a mid segment, then you can go with that premise. If they don't tell you like this problem, then you have to look for the marks, okay? That's just part of our Euclidean geometry. All right, let's move on to number 13. Okay. Right. There's going to be a little bit more to this one, looks like. The ratio of the sides of two rhombi is 2 to 5. Okay, now that is one dimensional when they said side. So we know that we have a 1D situation that is the actual value of our K ratio. Okay, the area of the larger rhombi is 300 square inches. Which one of the following pairs of numbers could represent the lengths of the diagonals of the smaller rhombus? Okay, so we have two things going on here. We need to get the area of the smaller rhombus, and then we need to deal with the diagonals. Okay, all right, so let's do that. Okay, the first thing that I notice is that they're saying uh, that we have area here. So that means our K needs to be, see, that's our K. So our K equals 2 over 5. So in order to use it with area, we need to square those. So we need 4 over 25. And we're going to set that equal to, okay, the larger rhombi, or rhombus rather, of the two rhombi is 300. And we are just going to call the smaller area x, okay? So we have 25x equals, well, I'm going to go ahead and just leave that as 4 times 300. Divide both sides by 25. That cancels out. And then this is what I will use, okay? But before we put that in the calculator, let's set up what we need over here. Okay, it says, which one of the following pairs of numbers could represent the lengths of the diagonals? Okay, so we need of the smaller. So we have what the values that we need for the area. So we're talking about the area of the smaller guy. Well, the area of any rhombus is equal to d, again, okay, that is equal to d1 times d2, which those are diagonal, divide by 2. Okay? Right now, let's put this in the calculator and see what we have. 4 times the 300, divide that by the 25, and we get 48, which is wonderful. Okay? All right, now, that means For that, the two diagonals multiplied together, that would be D1 times D2 equals, well, there's our 48. Multiply that times 2 and we get 96. Okay, that being said, now what we have to do is go through our options of A, B, C, D when we multiply and see which ones equal 96. Well, 6 times 8 is 48. That isn't going to work. 10 times 16, well, that's 160. That isn't going to work. And 10 times 32 is 320. That isn't going to work. Well, I bet that 16 times 6 is 96. Let's put that in the calculator. 16 times a 6 is 96. So option D is what we need. Okay, let's keep going. The ratio of the surface areas of two spheres is 9 over 100. The radius of the smaller sphere is 12. What is the surface area of the larger sphere? Okay, we're fine with this because we're working with area. So our scale factor is already in our k-squared, so we're fine with that. But we will need to find the actual surface area of the smaller sphere first. Then we can do our proportional setup. Okay. So, and you may think that I'm a little crazy, but this is how I remember this. Oh, and I think this is on your formula sheet, uh, the surface area for a sphere. And I know that the volume for a sphere is also on there, but I can't always remember it. So what I do is I can always remember this, which is pi r to the third. And I just take the first derivative. I know that is very crazy, but that's how I do it. So that means that my surface area is going to be, okay, 3 times 4 is 12. And then 12 divided by 3 is 4. So the surface area is 4r squared pi. Okay. I know that's a little strange, but that's how I wrap my head around it. So that's just a little tidbit that a lot of times you have a formula that's the volume, and then when you take the first derivative of that, then you're going to get your surface area. Give it a try on other shapes. But anyway, let's move on. Okay, so now we have that. So we can find that smaller surface area, okay? All right. Uh, that means that we have 4, and they gave us 12. So that's 12. Oh my goodness. Here. But will it let me? I don't know. There it is. Delayed reaction again. 12 squared and then my pi. All right, let's put that in the calculator. 4 times 12, and then square it, and we enter, and that's what we need. 576 pi, okay. Now what we need to do is take that value and set up our proportion. Now, as I said, our fraction is exactly the way we need it. We don't need to adjust it. So that's 9 over 100 is equal to. Okay, now the area that we have here is for the smaller sphere. So that's associated with the 9, which gives us 576 pi. And we'll just call the larger area x, okay? So now we have 9x equals the 100 times the 576 pi, divide both sides by the 9, and then this is what we put in the calculator, okay? So let's do that. So I have 100 times 576, divide that by 9, And that's correct. So we'll push enter. And that's our value that we need, which just so happens to be option A. All right. Well, let's go to number 15 here. I'm going to need room to write. I can already see this. Okay. The height of the larger of two smaller cylinders is 10. Height of the larger. So that's our larger one. Oh, wait a minute. 10 inches less than twice the height of the smaller. So what is that going to be? 2 times the smaller height minus 10. We've done some of these in other videos, so we already know that setup. And then of the smaller, and then we already know that we're calling that height x, okay? And the ratio of their areas is 16 to 24. Okay, that is areas. Okay, but if we want to find the value of the height first, then we need the k, not k squared. So we need 4 over 5 first, okay? Okay, now the radius of the smaller cylinder is 6 inches. What is the volume of the smaller cylinder? Okay, so first they want us to get the height of the smaller one. And then we use that height to apply to the volume formula to find the volume. Okay, so we've got 2 calculations that we need to deal with. Okay, so first let's deal with the one-dimensional situation, which is for the height. So that will equal, okay, that's x. The x is associated with a 4 because that's smaller. And then we have 2x minus 10. Okay, so that gives us 5x equals 4 times the 2x minus the 10. Okay, now we have to distribute. So we have 5x equals 8x minus the 40. Now we need to do some subtraction. Okay, so I'm going to say minus 8x and minus 8x from both sides, okay, of the equal. So what am I going to get here? This cancels out. We have minus 40. And then over here, we have the minus 3x. Divide both sides by minus 3. And then what do we get? Well, technically, because we can cancel out the negatives, we have 40 over 3. But either way, we can leave that. And now we need to calculate the other, use that to calculate the volume. Okay, so now we can do this. So the volume of a sphere, as I had, oh, actually, it's not a sphere. I'm sorry. Volume of a cylinder actually is base times height. And when you look on your uh, chart that they give teachers, I've seen a couple of different versions. And the one version that I've seen actually says base times height, and then they expect for you to know the rest. It's okay because we know that the base of a cylinder is a circle, and that is pi r squared. And then whatever that height is, okay? So for us, that means we have the radius of 6, so 6 squared. And now we know that the height is 40 over 3. And then we have pi hanging on at the end. Now look at your answer choices, your A, B, C, D. That is in terms of pi. So just leave pi hanging there, okay, just as we've done before. So what are we really going to put in our calculator? Well, we're going to put in 6 times 6 is 36 times 40. Divide that by 3 and leave that pi there. and we should get what we need, okay? So 36 times the 40, divide all that by the 3, and that's 480. Okay, and that gives us exactly what we need. All right, this is the last problem in this video. I hope you've enjoyed watching, and you've probably really gotten it became rather entertained when I make my small mistakes or my technology goes amiss. But anyway, thank you for watching, and please subscribe, like us, and share us. It'd be really great if you throw out a bunch of shares for us and see if anybody else would use us to study with. We have a lot more videos coming. Okay? Happy testing.